Good morning, students. My name is Ch.S.V.PRASAD RAO, and I am working as senior lecturer in EEE at Government Polytechnic, Yadgirgutta. I am handling the subject AC motors. In this lesson, fifth chapter is starters and speed control of three-phase induction motor. So, in this case, last class we covered methods of starting off three-phase induction motor and and what is the meant by DOL starter, that is direct online starter. And in this starter the full motor is full voltage starting, and we covered what is the necessity of starter, why it is required, what is the purpose of starter. So today we will cover about DOL starter and star delta starter. So today in this class we will cover DOL starter function with current and voltage graph versus rotor speed, DOL starter working with diagram, DOL starter torque equation, disadvantages of DOL starter and star delta starter function, star delta working with diagram, and star delta starter current and torque equations. In the last class we covered why starter is required. Anyone can tell why starter is required? Though starting of an induction motor involves change in its state, that is from rest to a steady state speed of rotation. The process of starting one of the most important phenomena in the entire operation of the motor. So this is the main important part, starting. So why the need of a starter? This is important question. Sometimes he will give what is the important necessity of starter. Suppose if starter is not there, if you connect the motor directly. So let us see what happened. I will explain briefly as I explained in the last class. When induction motor directly connected to the supply system, it take about 6 to 8 times its rated full load current at the time of starting. So this heavy current, although may not impose electrical stresses that are severe as for large motors, but such a large current flows through the motor winding. Then what happen if it is flows more current? Will cause a large voltage drop in the system, in the supply system. So then what happen because of the large voltage drop? Other machines connected to this supply system will be adversely affected. It is therefore recommended that large three-phase induction motor be started with a reduced voltage applied across the starter terminals at starting. Only at the time of starting we will apply a reduced voltage. So that is one reason how we can reduce the current, starting current. So the main disadvantage of starting with reduced voltage is a large reduction in starting torque. Whether or not such great reduction in starting torque is permissible depend on the application. So the following are the common methods of starting off three-phase induction motor. What are there? What are the types of starters? Direct online starter, auto transformer starter, star delta starter, and rotor restart starter. First three methods are applicable for both squirrel cage and slip ring rotor. So let us see how it will be useful. So you know what is DOL starter? Do you know that the DOL starter? Do you know the 3-point starter which is used for DC motor and the function of starter and what is the use of starter? So these points we are going to cover in this today's lesson. So what are the types of starter? First one is DOL starter, that is direct online starter. So in this case we apply full voltage start. So next one is auto transformer starter. So in this case what it will do, in this case it will apply reduced voltage. So next one is star delta starter. So in this star delta starter, what we will do, we will apply the reduced voltages. In this case also same thing. Next one is rotor resistance starter used for slip ring motor. So if you see, the first three are used for both squirrel cage and slip ring, and the fourth one is used for only for slip ring, that is rotor resistance starter. It is not used for squirrel cage motor. Note down this point. Four starters, types of starters. Noted. So these four are the starters which we are used for induction motor. So DOL starter, the main method of starting the AC motor is direct online starter. So this means an electromechanical mechanical switch is opened and closed to stop and start the motor, or DOL starter comprises a switch and an overload protection relay to this on and off. This is a mode stator. This is the stator terminals which are connected to the three-phase supply with a, what is this switch? It is called TPST, triple pole single through. This is the basic diagram how it is connected, DOL starter. In the next slide I will show the detailed figure, then you can note down. So what is the function of a DOL starter? The following graph shows how the current drawn by the motor when the starter using DOL starter. So these are the points: full load torque, full load current. So this shows how the current is drawn for a full load starter torque and full voltage start torque, full voltage stator current. So from this, if you note this curve, if you note this curve, note down this curve. This is the uh, curve between current, torque versus rotor speed. So from these points, when full voltage is connected across the stator terminals of an induction motor, large current is drawn by the motor. You understood? 1 minute I will show. So see here, when we connect to the motor at the time of starting, if you see this current, it is not starting, it is starting like this. When the motor is at the point of this is the speed and the speed is zero. What is the current? Very high. See here, the current reduces gradually when the motor increases the speed. When the motor reaches to 100% of the speed, the current is zero. And the torque also you can see the full load torque is less, but is increases as it increases the speed. So this is DOL starter is used for small motors. It is not used for high motors. Why anyone can tell? So why? Because for a big motors, large motors, the the current carrying capacity is more. Then what happened at the time of starting? As it carries 7 to 8 times of the full load current, the starting current is high. So it is used for only small motor. Here written when full voltage is applied across the stator terminals of an induction motor, then large current is drawn by the winding. This is because at starting the induction motor behaves like a short circuit transformer. So this high current will however be gradually reduces to a normal value as the motor picks up the speed. So these points are we noted from this graph. So for small capacity motors having rating less than 5 HP can withstand this high current due to robust construction. So it is not used for large motors. Next, motors are directly switched on from supply lines. Hence, the starter is called direct online starter. Direct online starter. Why? Because the name only it says it is directly connected to the supply. That's why it is called direct online starter. And direct online starter. So not only this one, it does not reduce the starting current. That is the main disadvantage of this DOL starter. It not reduces. It is giving the full current at the time of start. Next one is it consists of overload coil which protects the motor from overload. That is, suppose if voltage is more, then what happen? The overload coil will comes into action which will protect the motor. Next one is no load release coil which protects the motor from low voltage. Suppose if low voltage comes, then what happens? The output also reduces. Then automatically output reduces. It affects the application which is working on that one. That's why That's why we require no load release coil. This is the diagram for a DOL starter. Note down everyone. See here the supply is coming here. Three-phase supply. Here we have the main switch, and from there it has a contactor. From this contactor we have a magnetic coil. For that magnetic coil we are connected on and NC. NC means normally closed. NO means normally open. This is start switch. This is stop switch. Contactor will be there. Here actually the terminals like this. It has to extend up to here. Up to here it has to extend. So that means when it pushes, automatically all these terminals will be connected and the motor gets supply and starts rotating. Note down this one. DOL starter. Have to- It is important. So many times given the DOL starter. Note down how it is there. How it is connected to the supply. Yeah, always when you given the any starter for a 10 marks, we have to draw the figure and then we have to explain. For figure also we have the marks. So operation from this we have NO is equal to normally open and NC is equal to normally closed. At start on is pressed. The coil gets energized and contacts the contactor. So the starter directly gets the supply and keeps the contactor in on position. That means when we close the start button, that is normally open. Just you press and release. So when you press that one, then the current starts to flows through the contactor. When current is flowing through the contactor, then what happen? So the motor directly gets supply and keeps the contactor in on position. So if you suppose and it motor is started. Suppose if you press NC, that is normally closed is pressed. The circuit gets opened, due to which the coil gets demagnetized and the motor gets switched off from the supply. That means the current which is flowing through the contactor is interrupted. So when there is no current through that coil, automatically then what happened? Automatically the coil gets released and it opens the switch and it supply is off and the motor is off. And next we have the protection is over voltage protection. In this case, suppose under overload condition, then what happen? Overload comes, the current drawn from the motor also increases, due to which there is excessive heat produces. What happens generally when current is more, automatically the current is heat produced more. Then thermal relay gets opened due to high temperature and protecting the motor from overload condition. So, like this, the overload relay operates. I will explain once again. When overload comes, then what happened? The current drawn from the motor also increases. This current increases, more heat is produced. So when because of this, thermal relay gets opened due to high temperature and protects the motor from overload. So overload condition. So next one is short circuit protection. Features are provided for short circuit protection. So short circuit happens, high current flows, and then this uh, fuse will be burned. Next one is no voltage protection. If supply fails or low voltage situation, the circuit gets opened and is called as under voltage or no voltage protection. That means if suppose voltage is low or the supply is suddenly off, so then also the motor is stopped. So note, as explained in the above, DOL starter protects the motor from overload and no load and short circuit protection. Suppose if we see the torque equation, we have output is equal to 2 by ns T by 60. So torque is proportional to P2. So that is, but P2 is to PC is to PM is equal to 1 is to S is to 1 minus S. So power P2, that is the input power, is equal to copper losses by slip. Yes. So what is the copper losses? Copper losses are 3I square R2 by S. So that is equal to, so from this what you can say? We can say, see here, the torque is proportional to P2, but P2 is proportional to I2 square by S. So then what happened? So T is proportional to I2 square by S. If rotor resistance is R is constant. Now rotor current I2 is proportional to stator current I1. So T is proportional to I1 by I1 square by S or K. If you remove the proportionality constant, T is equal to K into I1 square by S, where K is the constant, is called proportionality constant. So it says that T is proportional to I square by S. So at starting, what is the slip at the time of starting is 1. So I1 is equal to IST. So starting torque is equal to K into IS square. So on full load, S is equal to SF. So I1 is equal to IF, full load current. Then what is the full load torque? KIF square by S. So therefore T starting by T full load. What is the T starting? K starting current square. And full load torque is KIS square by SF. So that is IST by IF whole square into slip. So this is the relation between T starting and T full load. So when the motor is directly switched on, to rated voltage, then starting current is equal to short circuit current. Then what is the starting torque? Starting torque is equal to full load torque into ISC by IF whole square into slip. It shows that starting torque varies as square of the starting current. So from this we can say starting torque is proportional to square of the current. So square of the current. So from this DOL starter, what we can understand. So once again I will explain the DOL starter. When full voltage is connected across the stator terminals of an induction motor, then what happened? Large current is drawn by the winding. This is because at starting the induction motor behaves like a short-circuited transformer. So this high current will however be gradually reduced as we seen in the graph to its normal value as the motor picks up the speed as we shown in the graph. In the graph we see that the time of starting the current is more, but it gradually reduces as the motor picks up speed. The current drawn by the motor when started direct online is shown. Suppose we are using push button type direct online starter. So it is simple, inexpensive and easy to install and maintenance. So these are the advantage of DOL starter. Note on this torque equation. So the push button type DOL starter is very common in use, very commonly used. Why? It is simple, it is simple, inexpensive and easy to install and maintenance. So it is simple as we compare to other starters. It is simple, inexpensive and easy to install and maintenance. So it consists of a what it contains, as I explained just now, it contains start and stop push buttons and a contactor. Just wait, I will show the figure, then you can understand. Here, here it what it contains as shown in figure. The figure shows the push button type dual starter commonly used. It is simple, inexpensive, easy to install and maintenance. It consists of set of start and stop push buttons. Here I can see this is NO and NC. NO is normally closed and NC is normally NC is normally closed. NO is normally open. So which one is start and stop button? So NO is start button and NC is close button. So the push button type DOL starter is very common in use as shown in figure. It is simple, inexpensive, and easy to install and maintenance. So it consists of a set of start and stop push button, that is NO and NC. And what it contains? It contains a contactor. Here this is the contactor, an electromagnet with its associates with contacts. These are the contacts. See here, contactor, and usually an over voltage and under voltage protection. So it contains these parts. What are the it contains DOL starter? DOL starter contains start and stop push button and a contactor, that is electromagnet with its associated contacts and an overload and under voltage protection device. So it contains these parts. So what is the purpose of this on button, on or start button? So this on and start button is a contact switch that is held normally open by the spring. The off or stop button is held normally closed by the spring. So that is the on button is what it says. The on button is normally open and the off button is normally closed by a springs as shown in figure. So when you press on button, where is the on button? This is open. As I told, on button is always open, and if you press this one, then what happened? It's closes this contact. When it closes this contact, then what happened? The current comes from here and here, that flows here. So when you close this one, then what happened? The current comes from here like this. It grows like this through this winding and it comes. So these two windings, it is closed. This loop is closed. So this is what a magnetic coil. So what happened when current is flowing through this one? The coil gets magnetized and it attracts the contactor. It attracts the contactor. That is when on button is pressed, the contactor coil C comes energized through off switch and overload relay OLR and its open contacts are closed. That is when on button is pressed, the contactor coil C becomes energized through off switch and overload relay and it comes open, contacts are closed. You understood this point? That is when you press this on button, then the contactor coil becomes energized. This one here you written a magnetic coil becomes energized and off button and off switch and overload relay and it opens contacts. This one will be closes. All these contacts will be closes. So then what happened when these coils are closed? It is connected like this. All these terminals are connected like this. So, so when on button is pressed, the contactor coil C becomes energized through off switch and overload relay, and its open contacts are closed. So this closes the main contacts and the motor gets connected across the supply. So that means this closes the main contacts and the motor gets connected across the supply. The motor continue to get supply even when the on button is open. Since the contactor coil will then get supply through the contactor terminal DT, therefore it is called hold on coil. So what is the meaning of this one? The motor continues to get supply even when the on switch is open. Why? Because the contactor coils will get supply through the contact terminals, and this is called hold and coil. That is, you press and open, then it is all are magnetized, and it pushes this contactor, and this all open contacts are closed. When you push the off button is pressed, the coil gets demagnetized and the main contacts of the contactor open and the motor stops. So that means when the off button is pressed, the coil get demagnetized. That is, here off button is what? Stop button, NC button. So then what happen if you press the NC button? The current which is flowing through the coil is disconnected. When the current flowing through the coil is disconnected, then what happened? The coil get demagnetized. When the coil get demagnetized, then what happened? It releases the contacts. That means when the off button is pressed, the coil gets demagnetized and the main contacts of the contactor are open and the motor stops. What is the meaning of this one? The contacts here again it comes like this open. If you press this one, NOL coil, NC coil, then what happened? The current flowing through the magnetic coil is disturbed and it get demagnetized and it releases the contacts. Then it will be open. Then it will be open. So when it open, then what happen? The motor stops. It will comes like this. All the contacts are open. There is no supply to the motor. So when off button is pressed, the coil gets demagnetized and the main contacts of the contactor are open and the motor stops. So if the supply fails or line voltage drops below certain value, then what happened? The main contacts are open and is called under voltage or no voltage protection. So suppose then in case of over voltage, in case of over voltage on the motor, then the contacts of the overload relay will open and subsequently the motor stops. So that is the fuses are provided for short circuit protection. So understood. So that's why the DOL starter is used for motors which are below 5 HP. So that is for small motors it is used. It is not used for big motors. So why? Because at the time of starting it, it gives more current. So once again I am explaining DOL starter. So what is contained the DOL starter? The DOL starter contains start button, stop button and a contactor with its associated contacts and a usually an overload and under voltage protection device. So, and what is the main application of this one advantage? It is simple. DOL starter is simple, inexpensive, and is easy to install and maintain. So it contains a start button, stop button, a contactor with its associated contacts, and usually an over voltage load and under voltage protection. So the on and the start and on button is contactor switch and is held normally open by a spring. So so this on and so this another one it contains off or stop button is normally closed by spring. Suppose if you press on button, so then what happens? The contactor C becomes energized through off button and overload relay and its contacts are closed. So this closes the main contacts and the motor gets connected across the supply. So when we connected to the supply, then what happened? The motor continues to get the supply even the off button is open. So why? Because since the contactor coil is closed and gets supply through the hold on coil. So suppose if you the motor is running, suppose if you want to stop, when you press off button, the coil gets demagnetized and the main contacts of the coil are open. So if the supply fails or line voltage drops below certain value, then main contacts open and is called under voltage or no voltage protection. So in case of overload on overload motor, the contacts of the overload relay will open and subsequently the motor stops. Suppose if you short circuit up comes, then what happened? The fuses which are there here will comes into contact and the motor stops. So that's why it is used for small rating motors, that is below 5 HP. So we have derived the torque equation, that is torque is proportional to square of the current. So at the time of starting the current is more but slip is 0. So that's why the torque is like this. So at the time of starting TF torque varies as the square of the current. So what are the disadvantages? Disadvantages is high inrush current. So it is 6 times the full load. current flows and it causes a severe problem. And next one is necessities over the installation. And next one is limits expansion. And next one is reduces service life of electrical components. So these are the advantages from both electrical point of view and mechanical point of view. You study this one, DOL Starter. If you have any doubt, we can cover in the next class. Thank you.